Morning. In our previous discussion, we have discussed about gross calorific value and net calorific value. To start with, what is calorific value? Calorific value is defined as amount of heat liberated when a unit mass of fuel is completely burnt in excess of air or oxygen. So this is called as calorific value. So we have two types of calorific values, what is GCV and NCV. We have discussed in depth what is GCV, what is NCV also. So the unit of calorific value is kilojoules per kg. So now let us see how to determine the calorific value of a solid and liquid fuel. The calorific value of solid or liquid fuel is determined using bomb calorimeter. The calorific value of gaseous fuel is determined using Boyce calorimeter. So let us see the construction and working of bomb calorimeter. The bomb calorimeter looks like this. So the bomb calorimeter looks like this. So let us see the construction and working of bomb calorimeter. So bomb calorimeter consists of a platinum or ceramic crucible in which known weight of fuel sample is taken. Crucible is placed in a well insulated stainless steel vessel which is known as bomb. So what is bomb? A well insulated stainless steel vessel is known as bomb. This bomb is equipped with oxygen valve and also electric ignition system. So the oxygen valve is used to supply oxygen. So we cannot open the valve and we cannot ignite the fuel, right? So therefore electric ignition system is there in order to ignite the fuel. So we have thermometer and also stirrer. This entire setup of the bomb is kept in a well insulated copper vessel. You can see this brown color, ash color copper vessel which is known as calorimeter. So this calorimeter is equipped with stirrer and thermometer and known weight of water. Let us see how does this work. So this is the construction, right? You can see that crucible is there. You can see electrical ignition system. You can see water, everything, right? So let us discuss the working. So the same thing, whatever I have explained, the same thing, the construction is over here in the points for your reference. Okay. So let us see the working of the bomb calorimeter. So the bomb calorimeter. So we're going to, before igniting the fuel, the initial temperature of water is noted down. So the fuel is ignited using electric ignition system. So when the fuel is ignited, so what will happen? The combustion occurs. You know that a known weight of sample will be taken. So it might be a liquid or it might be a solid. So known weight of fuel sample will be taken in the crucible and that fuel will be ignited using electric ignition system. So the fuel is ignited, so what happens? Spontaneous combustion will occur. So when the combustion occurs, carbon dioxide, water and energy will be liberated. So the liberated energy will be in the form of heat, right? So when the heat is liberated, that liberated heat will be absorbed by the surrounding water which is present around the bomb. So because of this, what will happen? There will be a slow increase in the temperature of the water. So we're going to wait until the rise in temperature is constant. Once the temperature rise is constant, you're going to note down the final temperature. So difference in temperature is calculated. So by knowing the mass of fuel taken, difference in temperature or rise in temperature and also the weight of water taken in the calorimeter and also the weight of other accessories in the calorimeter, the calorific value of the fuel can be calculated as follows. So mass of the fuel which we are going to take, let us consider it as mkg. Weight of water taken in calorimeter, let us consider it as W1 kg. And water equivalent of calorimeter is W2 kg. So why should we consider the water, weight of water in the calorimeter, weight of water? Because for instance, we are going to take this much water. Okay, we can see this is only hardly on 25 ml, right? We're going to take another 1 liter water. We're going to take another 1 liter water. Okay, so we're going to take this 25 ml water or maybe 100 ml water and this 1 liter water. We're going to ignite both at same temperature. Okay, maybe at 50 degrees Celsius at same time for same time. Okay, maybe for 5 minutes. So what will be the temperature rise? So 100% the temperature rise for this content will be high compared to 1 liter, right? So therefore the weight of water also plays a major role. Therefore weight of water taken in the calorimeter is also taken into consideration. So weight of water equivalent means that is weight of stirrer, weight of thermometer and weight of calorimeter. Why this is considered? Because calorimeter, stirrer, they are also conductors, even they absorb, right? So therefore we are considering even the weight of these also. So initial temperature is T1, final temperature is T2. So what happens when the amount of heat liberated by mkg of fuel, what will happen to the heat liberated by the fuel? It will be absorbed by the water and other accessories. So the amount of heat absorbed by the water can be measured. How it is measured? By rise in temperature, difference in temperature, T2 minus T1. So and other accessories. How will you measure the amount of heat absorbed by other accessories? So what are the other accessories? It might be stirrer, it might be calorimeter, etc. Right? So we're going to take even that weight also. So GCV is given by its amount of heat liberated by mkg of fuel is given by GCV equals T2 minus T1 W1 plus W2 divided by M. So that is calories per gram. So we're supposed to convert it into kilojoules per kg. So how to convert it into kilojoules per kg? We're going to multiply it by 4.187. So 4.187 is the conversion factor. When you multiply calories, the particular substance unit which is in calories per gram, into 4.187, it will become SI unit. Okay, calories per gram is a CGS unit. So if you are multiplying it by 4.187, it gets converted to SI unit. Okay, so now this is gross calorific value. So here we're going to consider the rate of the amount of heat liberated by what is that? Steam is also considered. So what is GCV? Amount of heat liberated in a unit mass of fuel is completely burnt in excess of air or oxygen, and the products of combustion are cooled to room temperature. What are the products of combustion? The products of combustion here are nothing but water. It is cooled to room temperature. Okay, so now let us see NCV. How to determine NCV? So NCV is nothing but, so NCV is given by GCV minus latent heat of condensation. So what is latent heat of condensation? As discussed earlier, when 1 gram of water vapor is cooled to water liquid, 587 calories of heat is liberated. So that is removed. But GCV contains that. So what is NCV? NCV is nothing but we want how much amount of chemical energy is converted into heat energy. How much amount of heat energy is hidden in the form of chemical energy. That is the exact heat, right? Energy is liberated, right? Exact energy liberated we want. So GC, you're going to consider the heat liberated by water vapor. We're supposed to remove that. Latent heat is removed. So GC minus latent heat gives you NCV. So NCV equals GCV minus, what is the formula to calculate latent heat of steam? 0.09 into percentage of hydrogen into 587 into 4.187. What is this 587? So in order to, when 1 gram of water vapor liquefies to 1 water liquid, it liberates 587 calories. So From where do we get water? We get from hydrogen present in the fuel. So fuel contains carbon, hydrogen. Carbon becomes carbon dioxide, hydrogen becomes water. So depending upon the percentage of hydrogen, we get water. Therefore, percentage of hydrogen is multiplied by 587. Okay, so by that we get this. 4.187 is the conversion factor, now to convert calories per gram to kilojoules per kg. So by this we can calculate the NC. Thank you.